Hello, I'm Dmitro, an electronic design engineer at Droid Technologies. I specialize in radio equipment and am responsible for the schematic and PCB design of the electronics, including signal verification, testing, and antennas matching designed PCBs. In this video, I will guide you through simple steps on improving the performance of your device's radio component with antenna impedance matching. We will begin with a brief overview of the theory and switch to the practical side, demonstrating each step on a real device that we have designed. Let's look at simple radio IC with a working output signal frequency range. Ideally, the output impedance of the IC must be 50 ohms throughout this frequency range for all work periods. If the impedance is different, we will need to add matching components near RF IC to achieve 50 ohms. Once we have resolved the issue and have 50 ohms, we need to have the same impedance on the working frequency in the antenna matching circuit. If the antenna along with the antenna's matching circuit has different impedances, we must select components to bring it to 50 ohms. Of course, we need to make theoretical calculation and simulation before starting to make experiments with tuning antenna matching circuits. However, these experiments will not be ideal because there are a lot of external parts that give parasitic inductance, capacity, enclosure, soldered components, and objects near devices. For a better understanding, let's look at the case where our RF IC doesn't have a 50 ohm output and requires additional components for the matching. In the illustration, there are L1, C1, L2, C2, C3 with antenna are matching components for an output antenna circuit which also needs to be 50 ohms. In our case, both circuits are required to be matched and reach 50 ohms. For this, we will use a vector network analyzer that will help us to check the wave impedance across the working frequency range. On the table, we have a custom-designed board crafted by our team, along with connected vector network analyzer for the first circuit matching. Let's capture and analyze the Smith diagram to assess our current stage. Reviewing the diagram, it's evident that our wave impedance on the working frequency is not at the desired 50 ohms. This indicates the need for tuning parameters of the components. This diagram provides valuable insights into the direction we should take. After a brief tuning session, we achieve a much improved and closer match to the result 50 ohm target at the working frequency. We connected the vector network analyzer to the output antenna matching circuit and followed the same steps to obtain the Smith diagram. Examine the wave impedance at the working frequency. As we see on the diagram, the wave impedance is quite distant from the target 50 ohms at the working frequency. In this case, we need to make the tuning parameters of the components. After these adjustments, the result shows a significantly improved wave impedance, now quite closer to 50 ohms. The antenna matching is a complex process that demands patience and thorough verifications through testing. At Droid Technologies, we are here to assist your embedded design project, ensuring successful implementation and optimal performance.